Hello, I'm Gene Anderson. Thank you to ISFAL for this most prestigious award. I'm sorry that I'm not here in person to be able to accept it, but again, from the bottom of my heart, my greatest thanks to you for this recognition. I am the Director of Research at the D. McGee Eye Institute, where we work on a variety of projects related to lipid metabolism. It's been my great fortune to be part of ISFAL from its beginning and to be associated with all of the wonderful and generous lipid chemists and biochemists that participate in this meeting. It's not very often that scientists have a eureka moment, but a collaborator and I had one in the mid-'80s. It was about that time that Robin Irvine and Michael Berridge had discovered that activation of phospholipase C led to the hydrolysis of PIP2, the release of 1,4,5-inositol trisphosphate, which released calcium from intracellular membrane stores. This was a new discovery. I knew Robin from other meetings we had been to, and I asked him to send me some of the 1,4,5-IP3, and he did, along with other isomers to be used as controls. I was collaborating with an electrophysiologist at WashU named Joel Brown, and his forte was microelectrode impaling of neurons. And he worked with the limulus, the horseshoe crab. One of their photoreceptors cells were huge, and he could impale those cells with a 4-barrel electrode and inject all sorts of things into them and see what the electrical response was. His goal was to find a compound that mimicked light. I sent him those vials of these precious inositol phosphates, and his phone call to me said, "What did you send me? There's nothing here. I can't see anything." I said, "Trust me, Joel, they're there. They're just very precious, and there's not much of it. Make it up to the proper dilution and inject it." He called me back a couple of days later, excited out of his mind, because when he injected the 1,4,5-inositol trisphosphate, it exactly mimicked the light response. So this was the first demonstration for an invertebrate retina that light activation of the neural response was via hydrolysis of PIP2, release of IP3, which increased the intracellular calcium stores. And that was the basis of visual excitation in an invertebrate retina. It doesn't work in vertebrates, but in the invertebrate, that was the way it worked.